Hello people, did you hear? Oxygen went on a date with potassium. It went okay. Jokes apart, let's decode it. What if oxygen actually dated potassium? What will the process, or I must say, dating be like? Oxygen dating potassium and getting potassium oxide as a result. Let's understand this process, or I must say, reaction. But what is a reaction? Chemical reaction is a process in which one or more substances are converted to one or more different substances. This transformation of a chemical substance leads to the formation of a completely different substance which has different properties than the original substance. For example, oxygen and potassium reacts to form potassium oxide. So in a chemical reaction, a chemical change takes place. Have you people noticed the change in color of iron when exposed to air for a long time, or the setting of milk into curd, or maybe let's say even complex processes of digestion of food, respiration, etc. There is this one thing common to all. They all are different forms of reaction. We see these reactions daily, but what exactly is happening at that molecular level? There is a rearrangement of atoms that take part in a chemical reaction. Like in the case of a reaction between oxygen and potassium, there will be a rearrangement between the molecules of the two. In scientific language, you can refer to them as reactants. The substances produced as a result of a chemical reaction between these reactants are known as products. For example, potassium oxide. Let's again understand this concept with an example. The burning of magnesium in air to form magnesium oxide. So, what are the reactants in this? Obviously, magnesium and oxygen. Also, what's going to be the product? Magnesium oxide. But can anyone tell if a reaction is taking place or not? Characteristics of chemical reactions help us to tackle this problem. These characteristics are common to almost every reaction. Exceptions are always there. Let's understand all of them with different reactions to get a better grasp on the topic. Evolution of gas. Whenever two or more reactants react, then the evolution of gases like hydrogen, carbon dioxide, etc. might take place during the process. To make it simpler for you, let's understand this with the help of an example. The chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. To find whether the gas is hydrogen, we can bring a burning matchstick near the mouth of the test tube, and if it burns with a pop sound, then it definitely is hydrogen. Change in color. The transformation of reactants into products might be easily observed when a change in color is observed. For example, the chemical reaction between citric acid and purple-colored potassium permanganate solution is characterized by the change in color from purple to colorless. Change in state of substance. Have you people ever noticed a change in state of candle wax during combustion reaction? It's characterized by a change in state from solid to liquid and finally gas. Because the wax is solid, water formed by the combustion of gas is a liquid at room temperature, whereas carbon dioxide gas produced by the combustion of wax is a gas. We have observed this phenomena a million times, but isn't this side of process interesting? Surely it is. Next is change in temperature. Have you ever felt a change in temperature of milk while making coffee at home? Surely, it's a chemical reaction too. This change in temperature in reactions gives us an indication that the process is going on. For example, The chemical reaction between zinc granules and dilute sulfuric acid is also characterized by a change in temperature. Formation of precipitate. A precipitate is an insoluble solid that emerges from a liquid solution during a reaction. This can give an indication that a process is going on. For example, the chemical reaction between sulfuric acid and barium chloride solution is characterized by the formation of a white precipitate of barium sulfate. With this, we have wrapped an interesting portion of our chapter. Stay tuned for more amazing information. Thank you.